Class of 2015. We are the final year mechanical engineers, and what we have made as the final project is a tree climbing robot or a mechanism. Going into the components that have been made for building this robot are to an SNDS mode, wherein we are connected to an AC supply and taken out through parallel connection to 15 ampere and 12 volt and 15 ampere wires to a DPDT switch, which is a double pull double throw switch, which actually reverses the polarity and changes the direction of movement of this robot. Now this connection is further routed through a connection through a plug point inside this robot. From this plug point, it is again routed through each of these motors separately through the inside of these pipes. As now connected to the SLDS and DPTG switch, the specification of the motor is 12 volt, 45 kilogram centimeter torque. This torque itself is helping in self-locking of this mechanism when it is stationary. Along with this self-locking mechanism of this torque, the additional compression given by the springs over here push this mechanism onto the trunk of the tree in a much stronger grip. Is the open structure of this mechanism that we have built. It consists of two halves of semi-hexagonal shape. The frame has been made of galvanized iron grade 18 hollow pipes. What we see over here is again 6 tires, 3 of them which are loose and 3 of them which are powered. This is what is the power supply. This is the connection that comes from the SLDS, as we have discussed before, and we are plugging it into the mainframe of the robot. Another interesting feature of this robot is that it has it is adjustable to variable diameter of the tree trunks. This has been accommodated by using a variable spring mechanism, wherein this rod has been routed through a guide inside the hollow pipes. According to the variable diameter coming on this tire, this spring compresses such that it accommodates the increasing diameter of the trunk of this mechanism over the tree trunk. Right now over here we don't have the tree trunk. We will be trying it on a pipe, on a cylindrical pipe. This is the pipe, and this is how we clamp it over the tree trunk. So what we are doing over here is we are clamping closing the hinges of this mechanism. By applying pressure while closing, we get a compression over the tree trunk, which is favorable for us. An important thing to be noted over here is that the closing should be done as close as possible to get a 120-degree structure and have an equal force distribution. The mechanism is working on, we are first trying to move it upwards around this board. For this, we are first switching the DPDT switch in the upward direction, and this is the The motor climbs at a steady state of 30 RPM, and then when it reaches the required height, we can stop it by offing the DPDT switch. Off the connection, as you can see, the mechanism is self-locking and is able to sustain its own weight, hold its own weight by means of the torque, self-locking torque of the motor, and also because of the spring as we discussed before. Now let's try how it descends down the tree. Let's see how this motor works, how this mechanism or robot works. There are various applications to which this can be utilized. Now, you could give a universal clamp over this surface, the upper surface, and provide it with a sprayer, cutter, or a video surveillance systems, and use it to have an access on a high altitudes. Or else, another method in which we could improve this design is by, instead of using electric motors over here, we could try using hydraulic motors, wherein while descending, these hydraulic motors could be converted to hydraulic turbines and can be used to run a dynamo. There are many other applications to this robot that we have currently made, and for cutting off trees, for using an inspection of lampposts, repair of lampposts, examination of electric posts. You could also use this in a horizontal mode and go through an electric pole like this and examine each of the parts over there. And so forth. There are many other applications which you could think about. As I said before, this is a basic design on which we have basic foundation, on which there are many future scopes of development and modification that can be done and can be improved. Hi, I myself, I am Tanveer Nasir, and these are the guys who work behind this project.
I'm Anisha, Adil, Latif, Ashik,
Sajadi. And thank you for watching this video. Thank you.